listo? Buenos días, ¿sí se escucha? Muchísimas gracias a todos los que con ese tráfico que nos tocó hoy después de un día de puente, no nos pusimos a pensar que hoy era el primer día hábil de la semana. Damos la cordial bienvenida a Google, que en el marco de los 60 años que estamos celebrando aquí en la UNAM, los 60 años del cómputo en México, se están haciendo una serie de eventos relacionados con el tema. Y es así que Google nos ofreció en este marco de celebraciones traer a dos de sus mejores ponentes en este tema que, como les llegó la invitación a todos ustedes, es cómo mejorar todos aquellos servicios que Google tiene en la nube. Así que le damos la más cordial bienvenida a nuestros ponentes. Ahora Jimena va a hacer favor de hacer la presentación en inglés para dar inicio. Tenemos otros compañeros que están inscritos, pero casi estamos seguros que están varados en el tráfico. Así que sean muy bienvenidos, compañeros, y muy bienvenidos Google junto con el señor Wesley Chan. Por favor, adelante.
Gracias.
Jimena.
Buenos días. Pues gracias por estar aquí. Sí, estamos aprovechando que hay un summit de cloud esta semana en el Centro Banamex, es el jueves. Y pues tenemos a los conferencistas que vienen a ese evento, pero nos propusieron tener pláticas también en alguna universidad y pues se nos ocurrió hacerlo en la UNAM y presentarle sobre todo a directores de tecnologías que ya trabajan mucho con las herramientas de Google y con Cloud. Les voy a leer la biografía de Wesley, que es el primero que va a presentar. Tenemos a dos autores, uno es Wesley y otro es Mitchell. Atamel. Entonces, bueno, Wesley es autor de la serie mejor vendida de Prentice Hall, Core Python. Es coautor de Python Web Development with Django y ha escrito para Linux Journal, CNET y Inform IT. Además de ser ingeniero y promotor de desarrollo en Google, enfocado al desarrollo de herramientas de G Suite, presentador de G Suite Dev Show, desarrolla CyberWeb, una consultoría especializada en capacitación de Python. Cuenta con más de 25 años como programador, docente y escritor, 2 décadas orientadas a Python. Wesley fue uno de los ingenieros desarrolladores de Yahoo Mail. Cuenta con estudios de licenciatura en Ciencias de la Computación, Matemáticas y Música por la Universidad de California. Es miembro de la Python Software Foundation. Y bueno, para no cortar un poco la presentación entre los dos, de una vez les voy a hacer la presentación de Mete, Atamel. Él es desarrollador, developer advocate en Google, o sea, se encarga, digamos, de evangelizar un poco sobre los productos de Google. Actualmente está enfocado a facilitar el desarrollo con Google Cloud Platform, como desarrollador con amplia experiencia en Java y recientemente en C++, C#. Le gusta comparar ambos entornos de trabajo. Antes de trabajar para Google, formó parte del equipo de Microsoft, Skype, Adobe, EMC y Nokia, donde realizó aplicaciones y servicios para plataformas web, móviles y de nube. Originario de Chipre, actualmente vive en Greenwich, no muy lejos del primer meridiano. Ok, pues muchas gracias a los dos por estar aquí. Thank you very much to visit Mexico and to have some time for our universities. Espero que todos disfruten la plática. Por favor, no duden en hacer preguntas. Vamos a tener más o menos 1 hora con cada uno, un poquito menos de 1 hora porque ya empezamos tarde, pero no duden en hacer muchas preguntas y también pues si tienen alguien más que pueda venir en este momento para acá de la universidad, creo que es una muy buena oportunidad. Gracias.
Okay, buenos dias. Thank you, everybody. Can you see? Okay, yeah, probably good to turn dark. Okay, so I'm going to introduce the Google Apps APIs. Why is that? Because the university uses Gmail and Drive and Calendar. Since you are in the IT staff and faculty, there are situations where you want to be able to automate certain things, to code these things. so that it's not just for users, but you can actually write processes and you can write work to do things behind the scenes. So that's why each of those tools have APIs. Okay, so this was the original name of the talk, the Google Apps APIs, but unfortunately, oops, I keep thinking that this is working. Okay, but unfortunately, we're changing the name of everything, so it's not Google for Work anymore. It's not Google Apps anymore. It's now Google Cloud, and it's called G Suite now. Okay, so yeah. So anyway, so I'm going to show you how to program apps using the G Suite APIs, or really, it's just a G Suite developer introduction. So power your apps with Gmail, Drive, Calendar, Sheets, and Slides, and more. So more than just being a user, now you're coding this stuff. Okay. Okay, so we already did my background, so you don't need to talk about me, but I'm a teacher, and I'm a book writer, and I'm a software engineer. So that's the important thing. So my job is to make sure that developers are successful using G Suite and other Google developer tools and APIs. I'm the host for the G Suite Dev Show. Jimena already mentioned that. So it's just a set of videos that show developers how to start coding using our APIs. It might sound really hard, so my job is to make it not so hard to get started. Okay, and so I write on the blog as well for the G Suite developers, and we have a Twitter account. And then you already know my background. Okay, so this is a technical introduction to our developer tools and APIs. I'm going to show you how to use our APIs. I'm going to demonstrate API usage. You can either use your programming environment, in which case you can use our REST APIs, or if you want to have your code living in our environment, we have Google Apps Script and App Maker for that purpose. For people who are not engineers, they're also developers. We can show that you too can succeed using our platform. You do not have to be an engineer. So you can choose either our customized version of JavaScript that we have, or you can use any language that we support, and then I'll kind of describe what all of those languages. And then there's also a trend to do more serverless computing because we're moving to the cloud, and in that case, you don't really have to have a machine, and in some cases, you don't even need to get a virtual machine. You can actually host and run your code just on Google servers without even thinking about machines. You just will run the code. Okay, so that's the trend. All right, so normally when I give this talk, it's to developers, and I tell them this is a really good way to make money because a lot of customers use G Suite and Google Apps. A lot of people around the world are using Gmail and Drive, so if you write applications that are useful for them, they will pay money for it, okay? So I always tell them you can make money fast. All right, so G Suite is all of these different tools. We already know about Gmail and Calendar and Drive and Doc Sheet Slides, but there's a few more. There's some administrative stuff. There's also Google Plus for your domain, and there's also Google Hangouts, and then pretty soon there's going to be a new Hangouts chat, which I will talk about as well. Okay, so again, G Suite is used by a lot of companies, and of course it's used at schools, including here. All right, and what happens is if you write an application and you want to start making money, you can put it in the G Suite marketplace. So these are third-party tools that are written by independent software vendors that want to make their software available for G Suite users. As you can see, there's a CRM tool. There's a tool that helps you with communications. So all of the tools that are in the G Suite marketplace have a very tight integration with G Suite tools and applications. Okay, so that's where you would put your app once you create it, but not for you guys necessarily, because you guys are going to be writing stuff specifically to help the university run more smoothly, to make it to do more automation and things like that. Okay, so there's a lot of data out there, and so this is kind of a talk I give to scientists as well. Is that you're doing a lot of work. You're crunching a lot of data, perhaps using the Google Cloud Platform or some other machine learning. But at the end of the day, no matter how much research you do or how much research the faculty does, you still have to convince management to give you budget, or you have to convince someone who's creating grants to give you money to continue your research, right? So the main idea is that while we know how to use these tools, it can be more powerful if you can code them as well too. Okay, so you can actually write code to use some of our machine learning tools, products that we have available. And then you can use like, the Sheets API to automatically put things into a Google Sheet, make calculations, do diagrams and charts. And then you can use the Slides API to generate the presentation. So you can actually go all the way from data science all the way to making a presentation to show your findings. So you can do everything from beginning to end using Google products. So I have all these tools here because we know how to use them as a user, okay? But there's a lot more to it than just being a user. You can actually write code, and that's why we have Google Developer Tools. So Google Developer Tools and APIs and platforms allow you to code using our technologies, or to take our technologies and integrate them into your apps. Instead of just using apps, you can actually make your own apps and use Google technologies inside those apps. Okay, so, and that, by the way, applies for web and mobile. Or more likely, for people who are doing more modern software, you probably have to do both. Okay, but a lot of people say, oh, using Google APIs is not easy, it's frustrating, okay, I don't know how to get started, like what do I do? Okay, so my job is to fix that. Okay, like I said, I do a lot of Python, so a lot of my code is in Python. Is just, if you don't do any Python, it's okay, just pretend it's pseudocode, because it's a language that requires very few lines of code to get something done. And so it's very easy to do a demo using Python because there's not a lot of lines of code on screen. Okay, so that's that. But like I said, you don't have to use Python. You don't have to use JavaScript. We support all of these different languages. So Java, JavaScript, C#, Objective-C, PHP, Dart, Go, JavaScript on Node, and then Ruby. So we support most major development languages. You don't have to use JavaScript and Python, but those are the two easiest to get started usually. Okay, so these are our Google APIs client libraries, and you can, if you just type Google APIs client libraries, you can easily find this page where you can go and download the client library for your platform. Okay. Okay, so I'm going to start kind of like talking about each of the APIs and then showing you code samples of how many lines of code it takes to actually talk to a Google API. Okay, and then on the right-hand side, generally I have sort of like what's the latest news over the last couple of years. Okay, just to kind of keep, so that you can keep in mind what's going on. Okay, so Google Drive, we launched a new API in December a couple of years ago. The previous version of the API is very, very popular. There's a lot of people that use Drive because Drive is at the middle of everything, right, of all your documents. Whoops. All right. Sorry. This happens at work all the time, as people know, right? Okay, where's my, where'd the presentation go? That's odd. Oh, maybe it's here. Okay. All right, yeah, so Drive is in the middle of all your documents. Okay, so there's a lot of users of Drive, including the previous version V2, so we have not shut that down yet. So V2 and V3 are living side by side. The main difference for V3 and the reason why V2 is still alive is because V3 is mostly performance improvements. So the network traffic is lower because the amount of data that we send through the API is less. Also, some of the API calls are a little bit faster. So there's really no, if your app works perfectly with version 2 of the API, there's no need to change. But if you want to take advantage of some of the performance improvements, then V3, it's change some of the names to make them make more sense and things like that. But there's no real large difference between how they work. Okay. Okay. So here's what I want to show you. This is the power of using our APIs. What you see here is code that will display the first 100 files and folders on your Google Drive. It's only, I don't know, roughly, 8 plus 6, 14 lines of code. So it's not a lot of code. And the other thing is that all of the stuff at the top is just authentication. That's the, that's the authentication and authorization part. The actual code to talk to Google Drive is as easy as I'm going to ask to connect to Google Drive's API version 3. I have my credentials that were authorized above. And now I'm going to just say drive files list execute. Give me all my files, or the first 100 by default. Okay, you can actually say, I want the first 50 or I want the first 200, but default is 100 if you don't say anything. And then it returns to you an array of all the files, and then you just loop through them. For every file, print the name and the MIME type. That's it. Okay, the code is only really 4 lines long. All this stuff is just to, whenever you run an app that you run for the first time, it brings up a little pop-up window, right? It says this application needs your permission to access your files on Google Drive, because your users have to have, your users have to give permission for your app to access their files, because it is protected user data. So that's why that screen comes up. Anytime you're asked for user data, authorized user data, you need to be able to give permission, right? Because otherwise, then you can write code that accesses everybody's Google Drive, and that's not what you want, right? So that's why you have to have the authorizations, all the security code at the beginning. But it's not that many lines of code either, at least not in Python. In other languages, there'll be probably a lot more lines of code. Okay, so this is all it takes. Also, if you're curious, if you want me to kind of describe more about each of the, how line by line how it works, I made a video for it. So. So anyway, so you can take a look at that. So that's the Drive API. Okay, not a lot of lines of code, and then you can start doing other things. This is not the only thing you can do, obviously, right? You can download files. You can say, for a Google spreadsheet that I have, I want to download a CSV, or the other way around, I want to import a CSV and have it upload into Google as a sheet. Okay, you can rename files, you can copy files, you can make folders. So you can do whatever you can do typically using the regular Google Drive user interface, you should be able to do with code. Okay, so there's functionality for everything. You can even watch for changes, like if you have a document and you want to know if somebody's updated it or added another row to a spreadsheet or something like that, you can actually monitor for changes. Okay, so the Drive API is pretty powerful, so you can do stuff with it. Okay, so now we'll talk about Google Slides. So we had a preview of this API in the summertime of Google I/O 2016, and then half a year later we launched version 1 of the API, and then since that time we've added sort of like more features to it. The most recent one is now we have support for Google Apps Script, and I'll tell you what that is sort of in the middle of the talk. All right, so Google Slides, how do you programmatically work with presentations from code? Okay, why do you want to do this? Well, one of the main reasons is you might have a lot of data sitting in a spreadsheet somewhere, but that's not, while you, as the person who's using the spreadsheet, understands everything, you may want to make it in a more presentable way because you might have a lot of data in a spreadsheet. Well, you can actually use the Google Slides API and auto-generate a slide presentation from that data. And you can have it tied directly to that data so that if you change your data in the spreadsheet, you can actually make it automatically update in the Google Slides too. So that's pretty useful. Okay, so that's one reason why you would do it. Another reason is maybe you're in sales. I know everybody's not in sales here, but maybe you're a salesperson, and you have 7 clients that you have to visit, and you want each of them to have a custom-made slide deck, right? So you have one template slide deck. You pull in the data for each of the customers, and then you can use the Slides API to auto-generate almost identical copies of the slide deck, except maybe the company name, the client name is changed, your contact's client name is listed in the slide deck. Okay, so you can actually do that. All right, so that's another use case. And then to get people to kind of like see sort of a nice demonstration of how the Slides API works, one of our engineers built a JavaScript runs on Node, and you can write an entire slide deck using the Markdown format, okay? And it will take that and it will auto-generate slides from it. So it's a pretty popular GitHub repo that we have right now. So. Can you imagine writing all your slide presentations in plain text, when you're on the plane, because you can't move your mouse and make it pretty or whatever? You can actually design your entire slide deck using Markdown and just have this tool auto-generate your slide deck for you. So I've done this with PowerPoint before with Python, so I totally understand the usefulness of something like this. So, okay, so how would that work if you were to write that application? So I have a template deck. Maybe I have a presentation name up here, title. Notice it's in kind of like a variable format. And maybe I have a place for the company logo for the client that I'm going to visit. So what I'm going to do is I'm going to ask the API to do two things for me. I want to search and replace all the text that I find that has this variable, curly brace title, and I'm just going to have it replace it with hello world because it's just a demonstration. And then for every place that I have a place where I have a sort of like a box that has the variable logo, okay, what it's going to do is it's going to replace that text with a logo, a product logo or a company logo. So I have to give the URL to the image, and then I want it to be centered inside the box where the logo was located. Okay, and so those are the two commands that I want, and then all I have to do is, okay, so by the way, all of this authorization code you see here is exactly the same. So I copy these first 10 lines of code, and then I put it up at the top here, and then the rest of this is the same, almost the same. So instead of creating an endpoint to the Drive API, now I'm going to create an endpoint to the Slides API. So it would be, slides equals discovery.build slides version 1, and then give it your authorization credentials. Okay, and then all you have to do is send this batch request, all of these requests in this array. This is the presentation ID number, and then execute. Fields is just empty. That's just to make it so that I don't expect any data back. Fields is what data do I want back from the API call. I don't want anything back. I just want it to happen. So that's why I say set it to 0 and then execute this. Okay, and it'll actually go through and the entire slide deck and make all these replacements. Okay, pretty fun. All right. Now Google Sheets. So we launched a brand new version at Google I/O in 2016. Version 4 is much more powerful than version 3. I think I have some slides on that. And then we added rotating text, after that, and then adding developer metadata, which is very powerful. I don't have any real content on metadata, but it's really important because what if in a spreadsheet you have data that's related to this spreadsheet, but you don't want to put it in the spreadsheet? Like, when was this data uploaded? All right, so you have a lot of data in the spreadsheet, but one of the fields is not last updated timestamp, right? And you want to put it in there, but you don't want people to see the last time your spreadsheet was updated, right? So it's data that's related to the spreadsheet, but you don't want to actually put it in the spreadsheet. So that's what metadata is. It's a way to kind of identify information about the data that's in the spreadsheet without you having to put it in the spreadsheet for people to see. So that's what metadata is, pretty powerful, okay? All right. So previously, in all the older versions of the Sheets API, you could only create new sheets within existing spreadsheets, and you can only add data to sheets, and of course, you can certainly read sheets. Those are the only 3 things you could do. But with version 4, you can do everything else, like create new spreadsheets from scratch, set frozen rows like this, where you drag down the first row because it's the header column. You don't want it to scroll off. You can format numbers and text. You can enforce cell validation, adjust column sizes, apply formulas, build pivot tables, create charts. Basically, you can do everything with the API that you can do with the user interface. Okay, so it's much more powerful than before. So we expect this to get a lot of usage. Okay, and so again, why, just like with the Slides API, why do you want to use the Sheets API? Okay, well, you could have data that's in a database. You can't really look at it. It's not presentable to anybody. All right, so you can use the Sheets API to read it out of the database and then stick the relevant data that you care about in a spreadsheet. Okay, so that's one thing that you can do. And by the way, to get started, here's a medium-sized application, also written in JavaScript, running on Node. That is a customized reporting tool using Sheets. Okay, and basically, the idea is you are a manufacturer, a toy manufacturer, and you're registering toy orders coming from customers. All this stuff is in a database, and so the main idea is to kind of like use that sample data, and then you can convert it to real data, and then kind of like use it as a reporting tool. So, so you can try that. I actually use that database coming up in the code sample that we're going to look at. Another use case is, oops, did I press it already? Okay, yeah. Nope, yeah. So another use case is sometimes people use a spreadsheet as a database. It's not the best way to use a spreadsheet, but sometimes it's the most convenient thing. And also, it's a database that you can actually look at, right? It's visual. There's a user interface to it, okay? Sometimes you have data that goes from a database through the API into a spreadsheet, and sometimes it's the other way around. Maybe you want to allow your users to update something that's in the spreadsheet, but then you want those changes to flow back to the database. So that is also possible. Okay? All right, so let's look at example of one way, which is we're going from left to right, database to sheets. Okay? So I have data sitting in, this is the toy order database I was talking about. And also there's a video for this one too, in case you're curious. Yeah, so we have toy orders sitting in a SQLite database, and it has these columns. Okay, I can say, give me a cursor to this database. I'm just going to do select all, grab all the orders, and then I'm going to insert all those rows into an array, and then this will be row 0. So I put that in row 0 because I want header followed by data. Okay, and then just like before, copy all of that authorization code. Up at the top, you create a connection to the Google Sheets API, and then you could say, here's the data for the spreadsheet. I'm going to create the spreadsheet. Here's the data, the metadata for the spreadsheet. I want to get the spreadsheet ID back. Please send it back. So I execute this, and then from the results, I get the spreadsheet ID back. Now that I have the ID, I can put stuff into the spreadsheet by doing spreadsheet values update. Here's my ID. I want to start with cell A1, and then I want to take all the rows that I just grabbed from the SQL database, and then I'm just going to write those raw directly into the spreadsheet. And that's it. That's all you have to do to take SQL data that you read out of the database and stick that into a spreadsheet. Okay, of course, there's a lot more things you can do. You can make it right in different places. You can put header rows. You can format things. All right, so this is not the only thing, but this is a very easy way to move data from an SQL database into a Google Sheet. All right, another example is now, let's say once you move the data in, I want to do some formatting. You know, the first row with the column names, I want to make that a frozen row, which means I'm going to pull down that little line so that it stays on the screen even if my data scrolls off. And then the other thing is I want to bold the first row. Okay? So frozen rows are a spreadsheet property, so I'm going to update a spreadsheet property. Which one? I'm going to update grid properties, and I want my frozen row count to be 1 because you can only go from the top and go down. You can only have 1, 2, 3, or 0, 1, 2, 3, 4, 5. You can't make certain rows be frozen. It has to start from the top. Okay. Then the other thing I want to do is I want to bold all the cells in the first row. So this command is repeat cell, which means I'm going to start at row 0, and I'm going to go only up to, but not up to row 1. Okay, so the first row, even though in the spreadsheet it says it's row 1, internally it's row 0 because programmers start counting at 0, not at 1. Okay, so go from 0 up to, but don't include 1. What do I want to do? I want to change the user enter format, specifically the text format, and I want to set the bold flag to true. Okay, and then I want the affected fields to be user enter format dot text format dot bold. So this is sort of like another way of saying that. There's a reason why it's repeated because fields, I have an entire video specifically on fields because it could be really complicated. But the main idea is I can change things that is more than just the bold field. Okay, even though I specified I want it bold with the second line here, this is the command that I wanted to have it run. The field down here says all the things that I want to be updated. Okay, specifically, I want just the user enter format text format dot bold field to be updated. If I put other things here without specifying them up here, that means I can reset stuff. Okay, so maybe I had something that was italics. Well, I don't want to italicize anymore. Okay, then I would actually put user enter format dot text format dot italics down here on the fields line, but I don't have anything for italics on the second line. That means I want to reset the italics back to non-italicized. Okay, so the only reason why you see them both, it looks almost like it's being repeated. It's different. One is this is the action that I want to take, and this one is what are the fields that I want to have affected by that change. Okay, so like I said, it's a little bit complicated. So if you don't understand, that's okay. That's why I made 2 separate videos on it because it's a little bit complex. And then you take these commands, and then just like with Google Slides, I send these requests over, give it the spreadsheet ID. I don't want anything back, just execute it, and it's done. Okay, pretty basic. Okay, Gmail. Some recent things, nothing really exciting. I think most exciting thing is actually add-ons. So I'll talk about add-ons when I get to the app script section, but the Gmail API has been around since 2014. It's pretty stable. And it does all the stuff that internet protocols don't do. So if you guys have coded before and you're familiar with using like SMTP or IMAP or POP, okay, those internet protocols only work at the message level. They don't understand anything after that. But Gmail does more than that, right? It has labels, it has threads, it has vacation settings, it has a signature line on the bottom, right? Those things are not recognized by those internet protocols. So that's why we have an API. Okay? And so this is a simple example of displaying, let's see if this is the same code that I've used before. Okay. So what this does is it looks through all your Gmail threads and tells you how many messages are in each thread. So you can kind of see like what are your most busiest threads in your email. Okay? So the way this works is I'm going to ask Gmail to give me all my threads. And then for all my threads, okay, I want to get some metadata, which is I want to get the subject line. Okay, but I also want to get some of the headers because I need to pull out the actual subject line from the headers. Okay, and so if I don't have any messages in that thread, then I go to the next thread. So it's kind of rare if you have a thread that doesn't have any messages in it, but it's possible because you can go and delete messages. Okay, all right, so that's why I have this line here. But that's okay. Once I know I have messages, then I'm going to grab the first one, so index 0, the first email message in this thread, and then I'm going to loop through all the headers looking for the subject line. As soon as I find it, I stop, and if it's not blank, then I print how many messages are in this thread. So the length of messages, okay, which is how many messages are in the thread, and then the subject line. So you can see how many messages are in this thread, and then what the subject line is, so you can see which ones are the busiest. Okay, so that's basically how you would use the Gmail API. Of course, it can do a lot more things, like I said before. Okay. All right, calendar. Not a lot of things on the calendar side from the developer's perspective. Most of the changes for calendar have happened on the user interfaces or the mobile versions. Okay, but it's actually very useful to creating a calendar event. And I made a video for this one as well too. And the main idea is, let's say you're going to go and write a travel application, okay? And you're going to let them, your customers or your users book airline, hotel, and things like that. But if they want their airline reservation, their hotel reservation to be in their calendar so they can see it, they have to exit your app, then they have to go into Google Calendar, remember the dates and times of their flights and their check-in time and all those things before they're really done, right? So the question I ask is, well, as the app developer, why don't you put those events in their Google Calendar so they don't have to? All right, so that's one of the main reasons why you'd want to use Calendar, is to add events to people's calendar. Oh, and the other thing is a lot of people say, oh, doesn't Gmail automatically do that for you? And the answer is yes, but later on, what if you change those reservations and then you get another email? Well, guess what? Gmail will put another event in your calendar. One is going to be wrong, and the other one is going to be right. Which one, right? There's no control. It's only one way. So it's better if you're the app developer, because once you create a calendar event, you have the event ID. You can actually go and modify it. Okay, so if someone changes their travel plans, you can actually change what's in their Google Calendar because you've saved their event ID. All right, so it's much more powerful than letting Gmail automatically do it, okay, which is only one way. This is a two-way thing, okay? So the way you create an event in somebody's Google Calendar is you have to give the time zone, and then you have to say, what is the subject, when's the start time, when's the end time, and then are you inviting anybody? Okay, so this is dinner with friends, here are my friends. All right, then all you have to do is, again, the same authorization code. I create an endpoint to the Google Calendar API, and then I do gcal.events insert into the primary calendar this event body, and then send notifications to my friends so that they get the invite. And then I don't want anything back, and then just run this, and it works. Okay. So I made one video for this, but then the other important thing is making events is great, but you got to be able to change them too. So the second video I made for Calendar is about modifying existing events and also make them repeat, because maybe dinner with friends is great. You like those friends so much, you want to have dinner with them every month. Okay, so you can actually change it so that it's one of those, it'll recur every month and repeat. So that's what the next video is. Okay, now we talk about something interesting, all right, and that is Google Apps Script. All right, I don't know how many slides I have on Apps Script, but let me just run through it really fast. Basically, Apps Script is using a little bit of JavaScript running on Google servers. You can actually get access. You know, what I showed you with Sheet, Slides, Gmail, Calendar, and Drive, you can actually do all of that from Apps Script, and you don't have to worry about the authorization code. You don't have to worry about hosting your app. You just type it into Google. We host it, and you don't do any auth. So a lot of people like this better because it's a lot easier, especially when you don't have to do security. All right, so it's as simple as this. If I have a spreadsheet, okay, open a Google Sheet. If you pull down Tools and then Script Editor, you'll actually see this editor window here, and you can type something like spreadsheet.getActiveSheet.getRange set value hello world, and that will actually, and when you run this, it'll actually put hello world into cell A1 of that spreadsheet. Okay, so notice there's no authorization code here. It happens automatically. So a lot of people like this. Okay, so there it is. And of course, there's a video that goes with it. I don't have a private life anymore, okay, because I make videos for everything to show people how to get started. Okay, I mean, this is really basic, but if once you see this working, you get really excited, right? Because if you're not a programmer and you all of a sudden see hello world there because you wrote this code and you ran it, it's exciting because now you can think about what else you can do, right? That's where things start getting interesting, okay? So what can you do with this? All right, this is an address. All right, it's the address of Google's New York office. All right, what can we do with that? Well, with a little bit of help of Google Maps, you could get the spreadsheet app, get the active sheet, get the cell A1, pull the value out of cell A1. Well, actually, in this case, it would be A2, right? Okay. And then I could say, hey, Google Maps, can you create me a new map and put a pin or a marker on this address? There it is. Right? That's cool, right? That's 3 lines of code. Really, really short. Okay? And then better yet, maybe I want to tell my friend to meet me at lunch there. Okay? So then I could say, Gmail, send an email to my friend and send them the map, and then send them the link to the map. And then so in their Gmail, they can actually click on this and get that map so they can come have lunch with me. All right? Another video for this one. Okay? But the interesting thing about this, the most interesting thing, and the reason why I like this demonstration the most, is because this is only 4 lines of code. It is 4 lines of code that uses 3 different Google products: Google Sheets, Google Maps, and Gmail. You're not going to make a lot of money selling this, but it's kind of useful, or it could be useful, right? You could change it to something more useful for you. Okay, and it doesn't require a lot of code. Again, there's no auth, because auth is handled. When you run this the first time, you do see the window, you know, that little pop-up window that says you need authorization. The user, you need to give this code authorization to access your spreadsheet and to send email on your behalf. Those are the 2 permissions it'll ask for. You don't need, you only have read-only permissions for Maps. It's not your personal data, right? Okay, and it talks to the Maps API. I'm not doing any kind of API talking. I don't have to create an endpoint to an API. I'd have to tell it the version of the API like in the previous examples. Okay, everything happens automatically with AppScript, so that's why a lot of people like it. Has anyone done AppScript before today? Has anyone heard of AppScript before I started talking about it 5 minutes ago? Okay, generally I get 1 in 10. Okay, so all right, so you guys learned something completely new today. Okay, so that's good. Can I say muy bien? Sometimes I'll say mucho bueno. Okay, because my Spanish is horrible. Okay. AppScript is also what is powering what is called add-ons. So an add-on uses AppScript, but what you're doing is you're extending the functionality of existing G Suite tools and editors, like Docs, Forms, Slides, Sheets, and Gmail. Okay, so Docs, Sheets, and Forms add-ons came out in 2014. Slides add-ons came out Q3 of last year, and then Gmail came out Q4. So it's very recently we added Slides in Gmail. Okay, so another video I made is, let's say, how many of you guys take pictures, take photos with your mobile, and then you go home and then you download everything into a big giant drive, and you don't know anything about your photos. You just see the file names, right? Okay, well, guess what? You can now make slideshows from it, and then you can show your family where you went for summer vacation or something. Okay, so if you have a bunch of bunch of images, and you want to get them into a Google Slide presentation where you have one image per slide, this is the code that does that. So get the active presentation. I have a function that's 2 lines long. It just creates a blank slide and then adds an image. Okay, so we're going to use that a lot. So let's say I have 4 images. They don't have to be online, so it's easiest to demonstrate with existing online photos, but you could use photos on your drive, your Google Drive, or you can use photos on your computer. You can have them uploaded. Okay, you can update this code. But just to make it easy, I'm just going to choose 4 images that are already online. I'm going to, so whenever you create a new slide in Google Slides, a new slide deck, new presentation, it has a blank page, right, with a title and a subtitle. So now I'm going to set the title to be the name of this name, and then subtitle is Google Apps Script Slide Service Demonstration. And then for every image in this here, this is a for loop. It's going to loop through and call this function for each of these images. And then I'll have my slide deck. Okay, so that's pretty easy. All right. Yeah, so that goes to that. Okay. As you can see Google. Here's a subtitle. There's a title. Okay. All right. So the next thing is Gmail add-ons. This is even more powerful. All right. So let's say you travel, like I do. Okay. So I flew to San Francisco, by the way, just so you know. Well, okay, I lied. San Jose. It's a little further south, but most people don't know where it is, Silicon Valley. So I have a lot of receipts. I have a lot of like Uber receipts. I have an airline reservation. I have a hotel reservation. I have those receipts. They come into my Gmail. I wish I could do my expense report directly from Gmail, right? I just want to throw everything into a spreadsheet so then give it to my accounting people so they can give me my money back, all right? So I have all these things. Why can't we do it in Gmail, okay? You can if you use a Gmail add-on. So my summer intern last summer created this great Gmail add-on where it will actually read all the information from the receipt. It'll put it into a form that sits right next to Gmail. Okay, and then you plug in a spreadsheet, and then you click submit. I know it's hard to see submit. It's very lime green. And then when it's done, it says it's logged it successfully. And then what happens is if you do all your receipts, so it's in a panel that's inside Gmail, so you don't have to exit the Gmail tab to another app or to a spreadsheet or anything. You just hit, you just move it to the next message, click submit. Move to the next message, click submit. Okay, and then at the end you will have a travel expense sheet that you can give to your accounting people, and then they'll pay you back. Okay, so it's a really cool example. This is it's in the documentation. We have a code lab for it. We made a video for it. The source code for the whole thing is on GitHub. Okay, so you guys can get access to that. Just look for, just go to the Gmail add-ons documentation page, and then click on the samples tab, and then you'll get everything. Or you can just search YouTube for the video. It's easier that way. And then have all the links in the YouTube video description, so you can get that. It's a pretty fun video. There's 3 of us in it. So, okay. So here's some of the code, because you have to actually write not only the application part, which processes, using a regular expression, processes the receipt data, but you also have to write the code that builds this user interface to build this form. Because a Gmail add-on, you can do more than just this. So far, you only see text here, but you could actually make images. You can make buttons. You can make all kinds of things. So it's like a small user interface that you have access to. So this code creates the card. It creates here's the form that it's creating, right? Here's the card header. It says log your expense. Clear the form if there's a clear button. And then you could say, here's the new section. What is the name of the spreadsheet? And the code that does that will go and create a new spreadsheet if you want a new one, or if you have an existing one, it goes and opens it and adds data to it. Okay, and then once you finish building all the sections, okay, all the sections, section by section, once you're done with that, then you can just keep on adding them to the card. Add section, and then return the card that's done. And so Gmail will, the Gmail add-on will render that card that you built. Okay. All right, and then a little bit more boring, probably maybe more for you guys. Okay, for those of you who are admins and IT staff, is that the admin SDK will let you, not only create new users, because you could have, 500 new students coming in or new faculty members, right? You can automate creating Gmail accounts for them, Gmail accounts, calendar accounts, and things like that. But you can also do auditing. You can find out, how many people are using their mobile apps, or what kind of activities are they doing. You can find out what are the most active documents that people are working on, and you can find out what kind of apps are people using the most that access their Google Drive. So lots of different administration type things that you can automate using the admin SDK. Okay, so basically to be able to programmatically manage your G Suite domain, and I know there's a lot of domains here at the university, but you can do all these different things. Okay, probably not the reseller things and license things, but there are companies that what they do is they're resellers and they're VARs and stuff like that. Okay. All right, so I don't have any code with the rest of these because we're wrapping up. I don't want to take too much time away from Meta. But Google Classroom, so that's another thing, especially for schools, is that you can actually code coursework, look at the class calendar. So there's views for faculty members, for students, and also it can notify parents and things like that if you're younger students. So you can kind of manage. So Classroom basically manages all the assignments. It can do exams and grade exams and things like that. So Classroom API is good for that. There's also Google Vault. So for legal reasons, you need to have applications that work on compliance to federal laws, and if you have any legal things where you have to hold email to keep as evidence or things like that, you can program that with the new Vault API, which just launched less than a year ago. And the newest thing, which just came out 3 weeks ago, or is it 3 weeks? 3 weeks ago, is Hangouts Chat. So Hangouts Chat is only for G Suite domains. So we've all used Hangouts before, maybe, right? You guys have used Hangouts before. So this is sort of the professional version of Hangouts called Chat. And like I said, we just launched it. You have concept of rooms now. Okay, so you can have multiple rooms. And the best part is that you can it has a developer platform, and you can build chatbots with it. All right, so I'm giving a talk later tonight at the Google office in I was going to say in Mexico City, but we're still in Mexico City, so big. Anyway, the Google office closer to downtown, giving a talk on how to build chatbots. So how you can make automation. So you type something into a chat room, the bot gets it, and it executes stuff for you, and then it spits the output out in the same chat room. So you can do lots of cool stuff with it. Oops, already did that. Google Cloud Platform, so I'm going to let Meta go and describe that, but I was just going to give a demo of BigQuery to kind of show you this is how you would access BigQuery, and you do it exactly in the same way that you would talk to the other REST APIs. However, Meta will tell you that Cloud has an SDK, which is higher level than this, so you don't have to code at this low level, all right? But I still can, just because the rest of the G Suite APIs are at this lower level. So for me, I keep my authorization code the same, but I can talk to Google Cloud Platform products in a very similar way, okay? All right, so that is it. So as far as online goes, if you want to get started, we have 2 half-hour code labs. One is how to get started using the REST API, so that Drive example where you list the first 100 files and folders. That is the code lab to help you build it. Step by step, explains line by line the code. And then another introduction for AppScript. If you like AppScript, because I talked about it, it's interesting, that's great. And then links to some of the videos that I have. And then make a lot of money. And thank you. And if you actually want to see the video of me running through both of those code labs, it's very long. I did it in India in December. It's like a 2-hour video. Just put it on double speed. But anyway, if you need to reach me, I have a Google+, I have Twitter, We also have a Twitter for the G Suite developers as well too. And if you have any questions, after we're done, we'll try and field some questions. But if there's no time and you need to reach me with questions, then go to this short link and you can add questions into this Google Doc that's shared publicly as you guys ask the questions. And then when I get home at the next week, I'll answer as many questions as I can. Okay? All right. Thank you very much.
¿Tienen alguna pregunta? Creo que sí. We have some time for questions.
Oh, okay, sure. I also have my business card if you guys want to come down and grab it as well too. Okay,
si alguien tiene alguna pregunta, adelante. Y si no, por acá hay una question.
Okay.
I have a problem. Yesterday I want to take down a file and it makes an error. I can't put the file down in my computer.
Download a file?
From the drive to the computer. It says an error. How can I know what's the problem?
So it doesn't tell you what the error is?
No, it just tells an error.
¿Quieres decir algo?
Sí, tal vez el administrador tenga bloqueado que puedas descargar los documentos, solamente los puedas utilizar en Drive como tal. Pero eso es desde la consola de administración y lo debe de administrar.
Pero es mi archivo que yo hice y lo subí al Drive y luego ya lo quería bajar y ya no se podía bajar.
Pues tal vez después Ian puede revisarlo.
Sí, ahorita si quieres revisamos el programa.
Sí, y luego otra pregunta. Al usar las hojas de cálculo, todas no se puede uno poner que el símbolo del peso solamente sale en euros.
Esa es configuración, nada más hay que cambiarle la moneda a la que quieres.
Pero no aparece. Solamente tendré que poner alguna actualización de la versión.
No, lo que hay que hacer es configuración. Eso es porque probablemente tengas tu cuenta registrada como en España o algo así, por eso sale en euro. Nada más hay que cambiar la configuración de la moneda a que sea en peso y ya. Eso es muy sencillo.
Es que ya lo intenté. Sí, ya lo intenté y de todas maneras sigue apareciendo en euros, ¿no?
Ok, ahorita si quieres lo revisamos más específicamente. Sí, pero eso es configuración de Sheets. Es muy sencillo de cambiar.
Sí, gracias. ¿Alguien más tiene alguna pregunta?
Lo siento, I'm a developer. That's a user question. I don't know how to answer user questions. Sorry. ¿Hay más preguntas? Okay, I'll hand it over to Mete. Thank you. Oh, there's also stickers down here besides my business card, so. Cloud stickers are very colorful.
Yes. Okay, let's get started. Hello, everyone. My name is Meta Tamel. I come from London, and you wouldn't believe how happy I am to be here because it's freezing in London right now. It's -4 degrees when I left. And here it's like spring, like this is like summer in London. So I'm very happy to be here and to be talking to you as well. So this talk, I did this talk at Google Developer Days in Krakow and also Google Developer Days in Bangalore in India. And it's supposed to give you an overview of what Google Cloud is and what it can do for you. The audience I'm expecting to be software engineers or people who are familiar with software. But even if you're not a software engineer, hopefully you'll learn something from here. And by the way, this is my Twitter, and I already posted this slide somewhere on Twitter, so if you want to get the slides, just follow me and you'll have them. All right, so Google Cloud. Well, what is Google Cloud? Anyone knows Snapchat? Yes. Pokemon Go, the game? Yes. So these, they are built on top of Google Cloud. Google Cloud, it's a platform that enables you to build applications on. It provides computing, it provides storage, it provides BigQuery, it provides machine learning. So it's basically a whole platform that you can use to build applications. So Wesley talked about G Suite, which is one part of Google Cloud, and I'm going to talk about everything else. But it's a really big platform, so we won't go through it in detail. So my goal is to give you an overview of what Google Cloud is, and just at the high level, make you understand what it provides to you, and hopefully you'll be curious enough to go and check it out later in detail. So Google Cloud started with something called App Engine in 2008. Anyone knows App Engine or heard about it? Yeah, of course. So back in the day, Google created App Engine, and we did it in a really opinionated way. So we told people, if you write your code in a way that we tell you to write, we'll host it for you in a way that it scales. So just make sure that you write your code in this way with all these restrictions that we enforce on you. But if you do that, you get this enormous scale on Google Cloud. So that's what App Engine is. That was 2008, but unfortunately, people didn't really use it as much because there was a huge gap between what people were using and what Google was telling people to use. So back then, people were using basically just regular machines or virtual machines, and they weren't thinking of scale at the level that Google was telling them to think about. So what happened from 2018 to today is that, so we started with App Engine, and that's the way we tell people to write applications, and then we went backwards. So there's this gap, right? So we kind of built from App Engine back to where people are, and now we're basically getting people on that ladder. So we're basically moving people from physical machines to virtual machines to containers to App Engine and now Cloud Functions. So basically we're giving them a path to how they should do programming. So back in 2012, we had App Engine in 2018, and then we started building Compute Engine, which are virtual machines. Then we started building Cloud Storage, which is a way to store binary files in Google Cloud, BigQuery to analyze data. And that's all we had, like these 4 things. It was really simple. Now, if you look at today, this is what we have. We have more than 80 services, and I'm probably not including all of them right now, and it actually doesn't fit in one slide, you can see. So there's stuff on compute. So that's about how to run your code. This is about storage and databases. So how do you store your data? This is about networking. So how do you connect your services? Big data. So how do you capture big data? How do you analyze it? And how do you store it? Machine learning. Of course, machine learning is becoming really big. I'll talk about that. So we have APIs and frameworks to do machine learning. And then there's a bunch of things around it. So there's identity and security. There's management tools like Stackdriver to debug your applications, tracing, all that kind of stuff. Developer tools like Cloud Shell, where you can actually have a shell in the browser, and a bunch of other things. We won't have time to go through them. But as you can see, we went from one App Engine to 4 services in 2012, and now to more than 80. And there are more and more coming up every single day. So hopefully, I'll go through like the main ones and give you an idea what they are. Yeah, so this basically says that you have more choice now, but then people get confused because they're like, okay, what do I use on compute? Where do I store things? How do I store things? And in terms of machine learning, how do I use machine learning? Which API do I use? And these are legitimate questions. When you have a lot of choice, then it takes a lot of time to figure out what you should be using. So let's first talk about compute. So what I mean by compute is basically you have a piece of code that you want to run in the cloud, and what kind of options do you have in Google Cloud for that? So in Google Cloud, well, actually not in Google Cloud, but in cloud in general, when it comes to running your code, nowadays there's 3 distinct buckets that you can choose from. There's 3 distinct trends that you can choose from. The first one is virtual machines. So if you are used to having your own machine, then the next step is to basically virtualize that and then have a virtual machine and run that in the cloud. This is the one that's most familiar to people. So in virtual machines, you basically just define what kind of machine you want with CPU and memory, and you define what kind of storage you want, and you also define the operating system you want, Windows, Linux, and all these different flavors. And then once you have the machine, it's yours, and you can do whatever you want with it. More recently, people are moving applications from virtual machines to what's called containers. So containers, you can think of them as a lightweight way of virtualizing your applications. So instead of virtualizing the whole operating system and everything that goes on top of the operating system, you can virtualize the process not the operating system, the process and everything that goes on the process. So the process, your application, and the dependencies of your application, you can virtualize into what's called containers and run containers. The good thing about containers is that they are much more lightweight than virtual machines, so they're much smaller. And you can have multiple containers running on a single machine, and they're very easy to create, they're very easy to move around, stuff like that. So what we are seeing is that more and more people, they are moving from virtual machines to this containerized world using Docker and Kubernetes and things like that. And then the latest trend is serverless, and this is my favorite because I'm an application developer. I want to solve a problem. I want to write code for that. I don't necessarily care about the infrastructure. I don't care where it's running, how it's being scaled. In my mind, that's someone else's problem. It shouldn't be my problem. I have enough problems with the business problem that I'm solving. I shouldn't have to spend too much time on networking, or I shouldn't have spent so much time on storage or whatever, right? So for those kind of people, then there's serverless, and we'll talk about that in more detail later. But these are kind of like the three buckets that you have when it comes to computing. And you have to decide where you want to be, right? If you still want to do machines and own machines, then you can go with virtual machines. But if you say, I don't care about machines anymore, I just want to write my code and deploy, then you want to be in serverless. And maybe you want to be somewhere in the middle. Maybe containers is the right solution for you. But it's something that you have to decide up front. Just to let you know, most people are in this container space right now, and maybe they're thinking of going to serverless, but serverless doesn't do everything yet. So that's why they're in this container space. But containers by themselves are not enough either. So just because you took your application and containerized it doesn't mean that all the problems go away. You still need to maintain that container. You still need to make it redundant so that if one container goes down, there's another one running. You need to make it resilient, so you probably need a health endpoint to check if your container is running, and someone has to check that health endpoint and make sure that your container is running, and if not, create a new one. So that's why we have something called Kubernetes. Kubernetes is an open source container management platform. It came from Google, but now it's open source, and it's supported by Google, Microsoft, Amazon, all the cloud providers basically. So you would use Kubernetes to manage containers in production. And then most recently, we have something called Istio. Istio is another open source project to manage microservices. So you have containers, and then containers are managed by Kubernetes, but then on top of containers, you have microservices running in those containers, so you can use Istio to manage those microservices. So in Istio, you can do things like you can specify the rules between microservices, and you can say microservice A can call microservice B, but microservice A cannot call microservice C. So you can set all these complicated rules, and Istio makes sure that this microservice mesh, as it's called, is being respected and it's running. So you need to keep these in mind as you're working with containers. At some point, you need to use Kubernetes and Istio on top if you want to do it properly. Now, in terms of what Google provides for running your code, there's a spectrum when it comes to running your code. On one end of the spectrum, it's highly customizable. So if you want to have full customization in your environment, then you would be in this part of the spectrum. But if you want things to be managed and you don't necessarily care about the customization, then you would be on the other side of the spectrum. So on highly customizable part of the spectrum, there's something called Compute Engine. Compute Engine is basically what virtual machines are called in Google Cloud. You can get a Compute Engine with Linux operating system, or you can get one on with Windows operating system with different flavors. You can specify the CPU you want, you can specify the RAM you want, you can specify the storage you want, and then just hit create, and it gives you a VM that you own. It's all yours. It's fully customizable because it's your machine, basically. But the downside of Compute Engine is that since you own it, you are responsible of it as well. So if you install software on top of your Compute Engine, and that software has a new version, then you need to update that yourself. Google is not going to do that for you. There's also something called Cloud Launcher. Cloud Launcher, it's a marketplace for Compute Engine. So there's basically ready-made solutions available for you to deploy to Compute Engine with one click. For example, if you want to get a Windows server with ASP.NET Framework installed with SQL Server and IIS, there's a Cloud Launcher solution for that called ASP.NET Framework, and you can search for it, and then you can just say click, install this, and then with one click you can get a Compute Engine instance with everything already pre-installed. So these solutions, they come from Google, but they also come from third parties as well, and you can also create your own solutions and host them on Cloud Launcher as well. Now, on the other end of the spectrum, I talked about serverless, so there's cloud functions on Google Cloud. The idea of cloud functions is that you define a piece of functionality or some code that solves some business problem. You define the input to that function, you define the output from that function, and you also define how the function gets triggered. So that function can be triggered by HTTP call, or it can be triggered by a pops-up message. So there's a topic that you listen, and then if there's a message that goes to that topic, then that function gets triggered. Or you can listen storage. So let's say someone saves some file to some kind of storage that triggers the function, and then you can execute your function. So once you define that, you deploy your function, and Google manages for you all the way. Basically, that function is scaled, that function is maintained, that function, if it's not running, it's shut down. When a new request comes in, it will be created again. So it's fully managed basically. So it's completely different than Compute Engine, where you have lots of customization, but you're responsible. In Cloud Functions, you don't have any customization. You just define your input and output, but it's fully managed for you, so you don't have to worry about updating things or upgrading software, stuff like that. And then in between Compute Engine and Cloud Functions, we have something called App Engine. I talked about App Engine before. So the App Engine it's kind of similar to Cloud Functions in the sense that you define an application and deploy it, and then Google, under the covers, it runs it on virtual machines, but you don't need to worry about that. You don't need to worry about the machines that it's running on. Google starts with 2 machines, and it automatically scales it to 20 machines, but all that is abstracted away from you. So you just define, it's a little bit more than a Cloud Functions. It's not just a function. You define an application with front end and then back end and stuff like that. But once you deploy it, again, it's managed for you. So it's a little bit of like functions, but at the same time, it's using VMs under the covers to manage it for you. And then if you did the transition from virtual machines to containers, there is something called Kubernetes Engine. It's a way to run container clusters managed by Kubernetes in Google Cloud. So in Kubernetes Engine, you just basically with one command say, give me a Kubernetes cluster with 5 nodes. So that will create a cluster with 5 virtual machines. And then you can just say, schedule this container into my cluster, and Kubernetes Engine will look at your cluster and figure out where to schedule that node and how to run it, and make sure that it will also monitor your container and make sure that it's running. If it's not running, it will create a new one, all that kind of stuff. And then there are some tools around this. So there's Container Builder to build containers in the cloud. And there's Container Registry. This is a place where you can save your containers. So once you build your containers, you can save them in this registry in Google Cloud. And then once this is saved, you can deploy it to Kubernetes Engine, or you can deploy it to App Engine. It makes it really portable, basically. Because once you have your code in the registry, anyone that has access to that registry can get your container and run it in any way they want. So this is kind of like this spectrum. And then, as I mentioned before, you have to decide where you want to be in the spectrum. It's up to you. I prefer to be here as much as I can. And if not, then I try to go backwards. And when I'm at the virtual machine stage, I'm like, okay, I'm back to old times again, but I have to do it because maybe there's some kind of framework that's not working on App Engine or Cloud Functions, and that's why I had to go back to virtual machines. And keep in mind that when you're running an app in Google Cloud, you're running in the same network that runs Google Search, Gmail, Google Maps, YouTube, right? And all these products, they have 1 billion users or more. So the network is highly optimized for us because we want to make sure that we are serving our customers as fast as possible. But because we optimize the network, you also get the benefits. So when you deploy your app, you're running in the exact same network that powers these applications. So it's good to keep in mind. And this is kind of like the network that we have. It's a global network. You see the edges, and you see fiber going through the Pacific. So it's a truly global network that you will be part of when you deploy the Google Cloud. All right, so that's how you run your code. Now let's briefly, I wanted to show you some demos, but let's see if it's going to work. Because my computer is there, and I never did this before like that. Let's see. No, that's okay. It's just very hard to see from here. But maybe I'll just show you like briefly without actually doing the demo. But this is Google Cloud Console. And then if you want to we can't really see. So basically, one of these is a compute engine. And I was going to show you like how you can go to compute engine and then create a VM with different configurations and just do create and it will show up. But maybe I'll just skip that and just talk through it because it's very hard to do it from here. So let's just go back here. All right, so let's talk about storage. So how do you store your data on Google Cloud? When you think of storage, it should be easy, right? In the end, there's some bytes you want to write, so it should be an easy thing. But then when you get into details of it, then it becomes really complicated. Where do you store your data? What kind of data do you have? Is data structured data or not structured data? If it's structured data, do you save it on a SQL database? Then if so, is that SQL database going to be enough? And if it's not going to be enough, then do you need multiple SQL databases? Then if you need multiple SQL databases, do you need to shard your data? Then if you need to shard your data, how do you shard it? Then if you choose a sharding function initially, then you need to add more nodes. How do you do that? If your data is not structured, then do you use NoSQL? Then if so, which one? Right? There's all these questions that come and complicate the problem. But where do you store it? This is basically something that you can print and put it next to you. So every time you decide, maybe you can look at this. So I'll just go through this really quickly. So if your data is in memory, so it's not any persistent data, then there's something called memory store. And it's basically for data that lives in memory for some time, but then if it goes away, it's not a big deal, like game state or user sessions, so you can use that. If you want to use relational data, so if your data is structured, then we have two options. There's Cloud SQL and there's Cloud Spanner. Cloud SQL, it's manage MySQL, so it's MySQL managed by Google. And also, I think we also support Postgres right now. So you can also have managed Postgres from Google. And we also want to support SQL Server going forward, but it's not there yet. So basically, it's SQL servers managed by Google. And there's something called Cloud Spanner, which is also a SQL server that scales horizontally. And I'll talk more about Cloud Spanner later because it's very special. It's a special thing that I don't think many companies have. If you have NoSQL, so if you want to store unstructured data, then you have data store and Bigtable. They're pretty much the same, except Bigtable is for highly transactional data, so heavy read and write situations. So if you want to do like financial data where you have lots of updates coming in and out, then you would use Bigtable. Otherwise, you would use data store for your typical NoSQL database. It's similar to MongoDB, basically. If you want to store binary files, then there's cloud storage. In cloud storage, you have a bucket, and in the bucket, you just send your files. And cloud storage is globally available. So when you create your bucket, you can create your bucket in a region, but you can also create it in a global bucket, which means that when someone wants to store your data to your bucket, it will find the nearest place and it will store it there. So it's globally available. Then for block storage, so if you have your VMs and you want your VMs to have some kind of persistent storage, then you can have persistent disks attached to your VMs. And these persistent disks, they can be regular ones and they can be SSD ones for fast access as well. And then finally, there's BigQuery. So BigQuery, it's a data warehousing solution where you can ingest your data and run SQL queries against it. So it's, in that sense, it's a storage product as well because you have to first store it and then you can analyze it as well. So these are kind of the options. But when you decide, basically, you need to look at your data and decide what kind of data do you have. So if your data is structured, so if it's something like rows and columns, then you probably want to use some kind of relational database. So you probably want to use Cloud SQL initially. But then if you need to scale much more than a typical SQL server, then you will probably switch to Spanner. And I'll talk about Spanner shortly. But then if your data is not structured and your schema is not so set, then you'll probably want to use something like data store or Bigtable if there's lots of transactions coming in and out. There's also something called Firestore. So these are for Firebase applications. So Firebase, it's somewhat part of Google Cloud, but it's for mobile applications. So if you're already using Firebase, then you would use Firestore to do your storage there. And then if you just want to store files, then you would use cloud storage. So in cloud storage, you create your bucket. You specify whether your bucket is regional or global, and then you just send your files there, and that's it. Yeah, and Spanner. Let's talk about Spanner. So normally, when you talk about SQL servers, there's a dilemma, right? Like, so in SQL servers, they are strongly consistent and highly available, strongly consistent usually. But if you want to scale them more, then they won't be highly available. Because some of you might know there's something called CAP theorem, right? In CAP theorem, CAP stands for consistency, availability, and network partitioning. The theorem states that you can only have two of these properties, right? You can only have either CA, consistency and availability, or you can have CP, or you can have AP, but you cannot have all three of them. It's actually proven mathematically that you cannot have all three of them. So normally P stands for network partitioning. That's a given. You know, in any kind of network, you have things that are separate from each other. So there's always network partitioning. So the question becomes basically whether you have consistency or availability. So you have to choose one of them, right? So in traditional SQL databases, you have consistency. But then when you need to scale, so when you need to scale from one SQL server to multiple, you won't have availability. You will have eventual consistency, right? Like, so things will eventually be consistent. So things will be available, but they will be eventually consistent because you need to copy data from one to the other. Then in NoSQL databases, you can have the scale, but things won't be strongly consistent at all times, right? So you always have to make the trade-off. And in Cloud Spanner, you can have both, basically. In Cloud Spanner, you can think of it as a SQL server that scales horizontally. So you have strong consistency, but it can also scale. So you don't have to switch from SQL to NoSQL. You can stay with SQL, with Cloud Spanner, and you can add nodes to scale it out as much as you need to. And the reason why this works is because of Google's network. So Google's network is highly optimized, and it uses atomic clocks to do syncing. And because of that, they can do all this magic to make sure that things can scale while also providing strong consistency. But I have to warn you, Cloud Spanner is not for small projects because a single node costs a lot of money. I think it's like $3,000 to $5,000, something like that. So you wouldn't start with Cloud Spanner. You would start with something simple like Cloud SQL, and then you would switch to Cloud Spanner when you need it. All right, so that's storage, and now let's talk about big data. So anyone heard of MapReduce? Maybe? Yes. You know everything. So back in the day, there was a paper called MapReduce from Google, from people working at Google, that explained how to do big data processing. So if you have data and if you can process data on a single machine, then you don't have to worry about it because you can do everything on a single machine. But as soon as you have data that you cannot handle on a single machine, then you need to think about how you can process the data on multiple machines. And then immediately the problem becomes really difficult because you need to take the data, you need to split into multiple nodes, you need to process them individually on these multiple nodes, and then you need to combine the results, right? So your simple problem becomes quite complicated, and this MapReduce paper explained a framework to do that in a way that's kind of easy to understand, and how do you split that data and how do you combine it. So after this paper, there was a lot of other papers that followed. So there was a paper on Bigtable, there was a paper on Spanner that turned into a product. There was a paper on Flume and Millwheel that explained how to do big data processing in real time and other things. But most of these papers, they were papers or they were actual internal implementations that we use at Google. So Spanner, for example, even though we made it public recently, we've been using it within Google for a long time. Same as Bigtable or PubSub. So there were internal implementations. But what happened at the same time is that people who read these papers, they created Apache projects. So they created Hadoop, which is the open source implementation of MapReduce. They created Spark, which is the streaming implementation. They created like Pig and Hive and all these different open source implementations of these different products. So what ended up happening is that all the innovation at Google ended up with something called Dataflow. So data flow, it's basically a big data processing pipeline where you can define what your pipeline should do, and data flow makes that happen. But then if you're already running Hadoop and Spark clusters somewhere, you can bring those clusters to Google Cloud, and there's something called Google Cloud Dataproc that will take those clusters and run them. So with Dataproc, you can basically say, give me a cluster of Hadoop, and then run my job, and when you're done, tear down your cluster, and you have your result. So it makes it really easy to run open source clusters in Google Cloud. But we have this split because of the split in innovation within Google and outside Google. But when you do big data processing, there's basically a life cycle that you have to go through. So the life cycle first involves capturing the data. So you have to first of all get the data, and there's multiple ways of doing that. So you might be using Google Analytics, so that might be sending data. You can use Firebase, maybe your Firebase application is sending the data. You can use PubSub, which is publish subscribe messaging in Google Cloud. So maybe you're sending messages to PubSub. So somehow the data ends up in the cloud, but that's the capture phase. After that, there is the process. So you have the data and you want to process that. There's something called Google Cloud Data Prep. So this takes your data and it kind of massages your data in a way. So it basically fills the gaps. If there is some kind of problem with your data, it will try to fix it automatically. And it gives you a framework basically to take your data and clean it up in a way. Because most of the time, one of the biggest problems in big data is that data is not 100% correct, so you need to fix it a little bit. So Cloud Data Prep gives you that framework to fix it. And once you have your data cleaned up, you can pass it to Dataflow. So Dataflow, I explained to you, is how we do big data processing at Google. And there's actually something called Apache Beam, which is an open source SDK that you can use to write your pipeline and pass it to Dataflow. And Dataflow will take that pipeline and it will either do batch processing or stream processing. Because in big data processing, you can do two flavors of processing. One is batch, so you wait for your data for the whole day, and once you have it, you process the data. So that's batch processing. But then you can also do streaming processing. So as data comes in, you can calculate the data there. So Dataflow gives you a model to do that, to do that both batch and stream in a single SDK. So once you process the data, you need to store it. You can send it to cloud storage, which is the binary storage, or you can send it to BigQuery to analyze it later, or Bigtable if you want to just do pure NoSQL analysis. Then you can do analysis using BigQuery. You can do further processing with Dataflow or Dataproc, or you can do some machine learning. So we have something called machine learning engine, where you can take your data and you can do even further machine learning analysis on top of your data. And then finally, once you have whatever result you want to have, you can visualize it. So there's something called Data Studio. It's a way to visualize your data. It's like a dashboard, basically, that you can connect to one of these sources, and it will update automatically depending on your data. And then there's also something called Data Lab, which is, I think there's an open source project called Juniper Notebooks. You basically write Python code to visualize your data, and we can host that Python code in Data Lab. That way you can see even more complicated charts than Data Studio. But this is kind of like the life cycle that you have and the choices that you have when it comes to big data processing. All right. I had a demo with big data, but I'm thinking it will be really difficult to show it. So maybe I'll move on, and then maybe I'll come back to it. And the last thing I want to talk about is machine learning. So machine learning, it's becoming really popular. I finished school in 2005. It's been a while. And I did my master's thesis on machine learning, and it was about spam filtering. How do you take email and filter it as spam or not spam? Because back then that was a problem. And then once I finished school, I started working, and then in the industry, no one knew about machine learning. No one even cared about it. So I always thought that it would be an academic thing. But 10, 15 years later, now machine learning is becoming mainstream, and many people are using it, not because machine learning got easier, but because companies like Google and other companies, they build tools around it to make it more accessible to people. So I'll talk about some of those here. And when you look at machine learning within Google, I think this graph tells you everything. So this graph is the directories containing deep learning models in different Google products. And you can see the exponential growth from 2012 to today. So machine learning is becoming really big within Google and outside of Google. And when it comes to machine learning, again, there's two different ways of using machine learning. The first way is using someone else's pre-trained models. So what this means is that someone learns machine learning and they build a model using machine learning, and they give you an API to use that machine learning. And all you have to do is call that API and get a result back, right? So what I call this as the easy way of using machine learning, because in here, all you're doing is basically making a call to an API and getting some results back. But you don't really need to worry about like taking data, analyzing it, cleaning it, and training your model. Someone else already does that for you. You just consume it, right? So if you can, stay there because it's the easy way of doing it. But sometimes you cannot stay in there. Maybe you have some custom data and you need to actually process your own data and create your own model. So for that, there's the second way. It's basically creating and serving your own custom models. So in this case, you need to do more than just calling an API. You need to use something called TensorFlow, which is a machine learning framework. And you need to basically get your data and use TensorFlow to create your own model and serve it. So let's talk about this one first. So at Google, we have what's called machine learning APIs. These are ready-made APIs that you can call to use machine learning. For example, there's a vision API where you can pass in an image, and it will tell you everything about that image. So Google already built a vision model. You're just consuming that model. There's a speech API where you can pass in speech, and it will send you text back. There is video intelligence API where you can pass in some video, and it tells you all the things about that video. What are the scenes in that video, what the video is about, stuff like that. So there's all these machine learning APIs that we're building and we're exposing to people that you can use. I actually have a demo that I think I can show this one because it's not that small. So I want to show you a vision API. So this is the BigQuery demo that I wanted to show you, but it's very hard to read, so there's no point. All right, so this is a demo where we're going to pass in some images to Vision API and see what we get back from Vision API. So by the way, in any machine learning demo, you have to show a picture of a cat. That's a rule. So I'm going to start with a picture of a cat. So let's pass this. And I didn't build this demo, by the way. Someone did, so I'm just showing it to you. So this is a cat picture we passed in to our Vision API. It's a little bit hard to see, but what I want to show you first is we basically made one call to Vision API with this picture, and what we get back, you get a JSON back. It's hard to see, but you basically get a bunch of JSON with some labels, and I'm just showing the labels here in this graphical section. So basically, I'm just converting JSON to this graphical way of seeing it. But what we see here is that this says cat 99%. So Vision API is telling us that this is a cat, which is good. But then it's showing us that it's an animal, 96%. But it's showing us that it's British short hair cat, 93%. So it even knows the type of the cat. And there's a bunch of other stuff. It picked up the colors in the picture, so you can see all the color ranges in the picture. And then it's telling us whether this image is an adult image or a medical image or spoof image or violent image. So it's telling us whether this image is something we shouldn't show to people. So this is all done through the Vision API. Let me show you one more example. So if you have an image with text, yeah, this one, for example. Yeah. So this is telling us that it's a sign, 94%, but it's also telling us it's a traffic sign, so it's not any kind of sign, right? 90%. And it even picked, so there's some text here. It picked the text here, tree, kangaroo, crossing next, and it even tells you where it is this word happens within the image, so you can use that information if you want to. So it can pick text, but then it can also pick up people. So So let me show you a person example. So these are people. So what this is saying is that, maybe I'll just sit here for a sec. Thanks. So this is saying that this is a group of people, folk clothing, stuff like that, and they picked up some text, but then if I turn this on, you can see that it picked people's faces, and it's telling us their expressions. So this person, so I guess it's this one, whatever is green one, it doesn't have any expression, but this one is joy. So joy is full. So yellow is what? Which one is yellow? This one. So it's telling us that this person is very joyful. So it's picking up people's expressions from the image. And then this person is joy, stuff like that. You get the idea. And then one last one I want to show you is this one. So this is a stadium. So it's telling us it's a stadium, and it's a baseball stadium. And then it picked up this text, I'm guessing somewhere from here. But it also picked up a person. Can anyone guess which person? It's this guy here. So there's a guy on the billboard. So it picked up that person, joyful. But it also, so this is a known stadium, I guess, in the U.S. Maybe you know, Wes, you live in the U.S. This Citi Field Stadium, but I don't know where it is. But we can click on it, because Vision API already picked up that this is Citi Field Stadium and tell us where it is. So where is this place? New York? Yeah, so somewhere in New York, which is nice. So as you can see, like Vision API picks up everything it can from the image and then gives that information to you, and all you have to do is just make a call to it, just one HTTP call, and you get this back and use it in your applications. So let me just go back to my presentation, if I can. Is this one? Ah, yeah. And yeah, I mean, and there's video intelligence, which is quite interesting, translation, all that kind of stuff that you can play with if you want. If you go to Google Cloud site, there are demos for each that you can actually play with. And then, of course, sometimes this is not going to be enough for you, because let's say you have images that's custom to your business, or something that you're doing research and you can't use Vision API because it's not trained on your images. What you can do is you can use, well, now you have two choices actually. Before, what you had to do was use something called TensorFlow. TensorFlow, it's an open source machine learning framework where you can actually write your own machine learning code and train your own model and then use that model. And it's, as you can see, this is the landscape of machine learning frameworks out there, and TensorFlow is the most popular one. So if you want to learn one, I think TensorFlow would be the one. But recently, what we also produced, recently what we came up with is something called AutoML. So AutoML is kind of like something in between Vision API and TensorFlow. So instead of building your models from scratch, what you can do is you can pass your images to Vision API and tell them, train with these images. So it basically takes Vision API and trains Vision API with your own images without you having to do TensorFlow yourself. So we have Vision API, we have TensorFlow, and then in the middle there's auto machine learning, where you can customize these ready-made machine learning models that we have with your own images. But I don't have the slides for that yet because it's very new. I need to update these slides. So that's TensorFlow. You can use TensorFlow, like it's an open source project anywhere, so you don't have to run it on Google Cloud. You can run it on your own machine. But there's something called Cloud Machine Learning Engine, where we try to make it really easy for you to run TensorFlow models and serve them. So what you can do with Cloud Machine Learning Engine is that you can submit training. So you can use gcloud command and then say submit training and then pass in some parameters. So with this, you are basically building a TensorFlow model in the cloud, but all the details of getting machines and running your training on those machines, they're abstracted away from you. So you can just do this, and then it will just happen automatically. And then once your training starts, you can see it in Google Cloud Console. So you can see like how things are progressing. So it's almost like a service that you call and you get some progress. And then in the end, you can serve your model. So your model is trained. Now you want to expose the model to people so they can use it. So you can create versions. So this is the default version. Then you can create a new version. And you can just serve your model to people who want to use it. So it makes it basically really easy to train your models and then create an API so people can call that API, just like Vision API basically, but for your own models. And then finally, there's something called Tensor Processing Unit. So as you know, there's CPUs, and then there's GPUs for games and picture processing and stuff like that. And for machine learning, there's TPU. Basically, this is specialized hardware came up with Google that makes neural network training really fast. So it's specialized hardware to train models in the cloud. And I think that we announced them, but I'm not sure if they're publicly available yet, but they will be pretty soon. So we make it even faster for you to train your models using TPUs. And that's it. That's all I have. So if you want to learn more about Google Cloud, cloud.google.com, there are code labs. So if you want to try this out yourself, there's a bunch of code labs that you can do it on your own. So these are like short exercises to create virtual machines or to deploy applications, stuff like that. So you can just choose whatever you want and just do it yourself. There's a bunch of official training from Google Cloud. So code labs are pretty short exercises. Like they're like 10 minutes. But then if you want to have like a week-long training or something like that, there's a bunch here. And then I think we also have free tier. So if you want to use Google Cloud for free, you can. And if you go to this website, cloud.google.com/free, you can see what you can use for free. But basically, you get $300 for free that you can use it anywhere. And then every service has a free tier. So if you want to use virtual machine, you get one virtual machine, small instance for free. If you want to use App Engine, you can use a micro instance for free. So for everything, there's a free tier. So you can basically build a demo application or a hobby application and run it on Google Cloud for free forever if you want to. That's it. Thanks very much. I guess we have time for questions? Yes. Anyone has any questions? Someone has one, yes.
Hi. Is possible to upload a virtual machine image through cloud computing?
Virtual machine mesh?
See, I don't know, Bingware image, KB image.
I don't know.
Upload the image.
I don't know what's a mesh. What do you mean by
image?
Image. Oh, okay.
A virtual machine image.
Yes, I mean, what you can do, so there are images that are made by Google. So the images for Windows Server, for all Linux operating systems, stuff like that. But what you can do is you can get a virtual machine and you can install whatever you want on it. And then at some point you say, okay, take a snapshot of this. And then it will take a snapshot and you save it. And then next time when you create a virtual machine, you say, okay, use this snapshot. And it will just basically create that virtual machine with everything installed on it already. And you can, what you can also further do is that you can create what's called an instance group and say, I want to have this instance group. So basically it's a group of virtual machines using this image, and I want it to be auto-scaled, for example. So what it will do is it will create one instance initially, but then let's say more people are using your application, it will detect that and it will say, okay, let me just create more, and it will add more instances, and they will be load balanced behind a load balancer. So there's a lot of things that you can do with the virtual machines, even though I don't recommend it, virtual machines. Because I mean, sometimes you have to do it, I understand, but like more people are moving towards containers, because in containers, you can basically just say, this is my container, just run it, and everything is abstracted away from you, right? So that's the path that we want to go, at least that's my taste. But if you really like getting into details and trying to configure things, you can do it and create images from that, yeah.
Thanks.
You're welcome. Any other questions? Yes.
We already use the G Suite, Gmail, Classroom, all of that apps, But we want to know if all of these new apps are going to be in this G Suite, or we are going to pay more so we can use them.
So that's more a G Suite question, I guess, right? Are they going to pay more or less? Can you tell us?
Yeah. Well, we already use the G Suite, all the apps in the G Suite that are now, but I understand that there are going to be new apps, and they are going to be included in the G Suite, or we have to pay more. Mm-hmm.
Thank you. Sí, voy a contestar en español. Ustedes lo que usan es G Suite for Education y no tiene ningún costo, y esto va a seguir así. Acaba de salir una nueva versión de G Suite que es G Suite Enterprise for Education. Eso sí tiene un costo, pero no va a cambiar en nada las funcionalidades que ustedes tienen en lo que usan actualmente, ni los productos que tienen, ni nada. Eso va a seguir de la misma forma. Y en Cloud, pues ahí sí hay un costo por utilizarlo. Siempre hay créditos que les da Cloud, les da creo que $300. Ajá, exactamente. Sí les piden una tarjeta de crédito, pero no quiere decir que les empiezan a cobrar. Simplemente cuando se acaba, si ustedes no quieren continuar usando los créditos, dejan de utilizarlo y ya está.
De hecho, la tarjeta es solamente para que... La tarjeta de crédito nada más te la pide como validación de que no eres un robot. No te cobra cuando se te acaban los $300, te avisa. O ya no tienes crédito, te vamos a cobrar. Pero incluso, como mencionó, hay un tier gratuito. Entonces, si están usando aplicaciones nada más para demo de ustedes, que no tengan mucha concurrencia de usuarios, pueden tenerlo ahí por siempre gratuito.
Okay, thanks everyone.
Well, we thank you. You share your knowledge. Si nadie más tiene más preguntas, muchas gracias. Gracias.